You are with Augustus from Samog Library. In this tutorial, we are going to solve the real number system questions that came in the WASSCE June 2014 and November 2014. Now, let's go to our questions. Objective question 1 in June. Simplify 10 whole number 2/5 minus 6 whole number 2/3 plus 3. Objective question 34 in June. Approximate 0.0033780 to 3 significant figures. Objective question 1 in November. Correct 0.005854 to 2 significant figures. Objective question 2 in November. Simplify 3 whole number 1/2 minus 1 whole number 1/3 times 2 whole number 5/8. Theory question 1a in June. Without using tables or calculators, simplify 0.6 times 32 times 0.004 all divided by 1.2 times 0.008 times 0.16, leaving the answer in standard form or scientific notation. Theory question AB. When a fraction is reduced to its lowest term, it is equal to 3/4. The numerator of the fraction when doubled would be 34 greater than the denominator. Find the fraction. This was also in June. Now, theory question 13b in June. An operator star is defined on the set of R of real numbers by m star n equals -n over n squared plus 1, where m and n are elements of the real number system. If -3, -10 are elements of R, show whether or not star is commutative. Time for our solutions. I have in my hand a brand new FX991ES Plus calculator that's going to help aid us in our solution. So let's get to the board with our solutions. First question, which is objective question 1, which came in June. It is saying that we should simplify 10 whole number 2/3 minus 6 whole number 2/3 plus 3. Our first step is to convert the mixed fractions to improper fraction. And we do that by multiplying the whole numbers by the denominators and adding the results to the numerators. So 10 times 5 is going to give us 50. 50 plus 2 is 52. So we get 52/5 for the first step, minus 6 times 3 is 18. 18 plus 2 is going to give us 20. So we have 20/3 plus 3. Our next step, we find the least common divisor of these 3 terms. We have 5 here, 15, and of course, 1 is over here. So the least common divisor between these 3 terms will be 15. 5 goes into 15, 3. When you multiply 3 by 52, 52 times 3, we are going to get 156 minus 3 goes into 15, 5. 20 times 5 is 100 plus 1 goes into 15 is 15. 15 times 3 is 45. So in the long run, when we deduct 100 from 156, we are going to get 56. And 56 plus 45. 56 plus 45, we are going to get 101. So 101 over 15. So this is an improper fraction. So we can convert the improper fraction to mixed fraction. So 15 goes into 101. Let me take 6. So 6 whole number. 15 times 6 is going to give us 90. So 101 minus 90 is going to give us 11. So 11 over 15. And that will be our answer for objective question 1, which came in June. On to our question, objective question 34, which came in June. The question is saying that we should approximate 0.0033780 to 3 significant figures. And the rule of significant figures that we are going to use states that only trailing zeros of a decimal are significant. I'm repeating it again. Only trailing zeros of a decimal are significant. So these leading zeros are insignificant. And here we have 0 at the last digit. So this 0 is significant. So when we want to count the number of significant figures we have here, we have 1, 2, 3, 4, and 5. So first, second, third, fourth, and fifth. But our question is demanding that we approximate this decimal to 3 significant figures. So our concentration will be on the digit 7. So we consider the next number to the right, and that's 8. We ask ourselves, is 8 less or equal to 5? No, sorry. Is 8 greater or equal to 5? If it is greater or equal to 5, then we add 1 to the digit 7, which is going to give us 8. But in case it is less than 5, then we are going to ignore the number that we are going to add and just maintain the 7. So in the long run, our number, which is 0.000333780, is going to give us 0.0033. Since we are adding 1 to the 7, it will change to 8. Then our answer will be 0.00338 to 3 significant figures. In our objective question 1, which came in November, it is saying that we should correct 0.005854 to 2 significant figures. And here we are going to use the decimal rule of significant figures, which says that only trailing zeros of a decimal figure or a number is significant, meaning that our first significant figure will be 5, and our last significant figure, which is the 4th, will be 4. So if we are going to convert this decimal to 2 significant figures, we will look at the second one, which is 8. We'll look at the number next to 8, which is 5. 5 is greater or equal to 5. It's exactly 5. So we take it as 1 and add it to the 8, which will give us 9 over there. So at the end, it implies that 0.005854 will give us 0.0059 two significant figures. Our solution for objective question 2 in November, which says that we should simplify 3 whole number 1 over 2 minus 1 whole number 1 over 3 times 2 whole number 5 over 8. Our first step is to convert the mixed fractions to improper fraction. So 3 times 2 is going to give us 6. 6 plus 1, 7 over 2. 1 times 3 is 3. 3 plus 1, 4 over 3 times 2 times 8 is 16. 16 plus 5 is going to give us 21. So 21 over 8. Now we have 2 terms. There's 1 term, and the whole of this is also another term. So let me do cancellation here. 3 goes here, 1. 3 goes into 21, 7. 4 goes here, 1. 4 goes into 8 is 2. So finally we are going to get 7 over 2 minus 7 over 2. And when we deduct 7 over 2 from 7 over 2, you are going to get 0.